timer is switching on and off. The Alexander cell has been activated and it's going from corroding to protected, showing the switching. The settings on the TR are about 3 volts and the swing on the DCVG is from 4.489 to 3, from about 489 to 3. So that's 489 on, 3 off. That's in millivolts on the central meter here. Now what I'm going to do now is I'm going to switch the picoscope on, hopefully. It's the oscilloscope. No, come on, stop looking about. And when and if I can get the oscilloscope switched on, I will then attempt to get the data logger switched on. I think it might be switching itself on now, the picoscope. Yes. Once it's switched on, I have to change it from sound, because it's got a built-in sound receiver, a microphone in here. I will have to switch it from the sound mode into the scope mode, because the scope probes are attached between the black and the yellow terminals on this breadboard. Now the breadboard doesn't seem to be connected, or it doesn't act as if it's being connected to the ORAC, but I've just checked ORAC and that seems to be functioning okay, because the Alexander cell is functioning and the DCVG, the 2 half cells, they are functioning and shining it on there. Now you can see the scope has switched on now, and it is in fact on sound, and you can see the sound on the scope. Right, now what I'm going to do is to toggle the sound off and the scope on, and we can now see the voltage here, and the voltage is at about 0.6 volts, and that is because I've got the this dud battery in here, which is being measured across the breadboard circuit. I'll look at that later to see how I can connect that to ORAC, but at the moment it doesn't seem to be connected to ORAC, and it doesn't seem to be reacting as I had hoped it will. But I've just sorted ORAC out, so maybe I'll be able to sort out the two of them. But the purpose of this little exercise now is to actually record the DCVG voltage variations between the two half cells whilst the cathodic protection system is being switched on and off. So I've got the CP system negatives connected to the test post here and to the ground bed which is underneath, and I've connected them through this red lead here which comes from the transformer rectifier and sends the charges into remote earth here via a whole ground bed of resistors, as you have seen underneath Aura. The breadboard is connected to the positive to remote earth through here and to the negative through a test post here. So at the moment I can't see why the oscilloscope is not actually reacting to the switching of the transformer rectifier, but it isn't. So I'll have to fix that later. Now I'm going to change the batteries to show that in fact I'm being given notice that one of these is, now that is changed, that's the battery, the rechargeable battery which is fully charged. That is onto the breadboard now and it's connected to the breadboard, negative rail and positive rail that goes through here to the goes through here to the oscilloscope. And now I will try to activate this piece of software which is through the RS232C connection from this multimeter, which then makes it into a data logger up on here. I'm hoping, if I slip this down, oh, this is switched off, that's handy. Switch this back on and now try to activate this. Activated that. Now let's bring this down here. Now this is as found before I've activated the RS232. I push this for a second and then I USB connect here, and we now have a record of the switching. So you can see it recording this switching session, and you can see this is seconds and milliseconds across here, and this is the on-off switching. So we can now see that the oscilloscope is not actually it's not connected to the cathodic protection system, otherwise this would be switching and it will be trying to protect or stop or equalise out the charges in the battery. So I've not got this correctly, the circuit is not correct for this particular little piece of Technotoy to work. But the bit that I was anxious to test out is the Alexander cell is a corrosion cell, and this is corroding when it's off, and it stopped corroding when it's on. So in other words, this is showing actual corrosion current being influenced by the cathodic protection system, because the anode of the Alexander cell is connected to the pipeline in ORAC. And the two base plates are connected to remote earth, and this is the cathode and this is the anode. So you can see the results of those measurements along here. So this is the on and the off measurements being logged on this data logger. Now the interesting part is when I put the roving half cell onto the anode, you will see that the readings change. Now we'll leave it there for a couple of cycles, on and off. And now I will move it to the cathode of the Alexander cell. And you will see the difference in the profile of the voltages. Now this is not waveform, this is, each one of these is a separate voltage. So I'll go back again to the anode of the Alexander cell. Now we'll now go back to the cathode of the Alexander cell. You'll notice that the direction of the corrosion current is changing in time with the switching on and off. I will now put the roving electrode back in its position in contact with remote earth, and you will see the difference in the voltages that are being logged, and this is exactly how we log the voltages on a DCVG survey in the field. It's exactly the same. So I've set it at 1 second off and 1, 2, 3, 4, 5 seconds on, and that's shown in the log which is shown on here. Right, so anything else to explain whilst I'm filming? No, I don't think so. That's all I can put on this particular clip of the film, which I'm going to have to try to edit. I'm not very good at that. Okay, so I'll switch the film camera off and take some still photographs.